All right, in this video, we are adding and subtracting mixed numbers, but we're actually going to do it when we have an improper fraction and when we have to borrow. So our objective is I can add and subtract mixed numbers using LCD that require improper fractions and borrowing. So just a reminder, LCM means least common multiple, LCD means least common denominator, and these two work together. They go together. So finding the least common denominator is the same process that we use to find least common multiple. The reason we change it to LCD is because we're working with fractions. So LCD tells us what numbers we're using, which is the denominators. All right, so let's look at two problems here. So our first problem is 1 5/7 plus 2 3/4. So again, we look at the denominator to find least common denominator. These are unlike, so we have to change them to make them like. So that's when we do our multiples of 7 and 4 because that's our denominators. So we have 7, 14, 21, 28, 35. I usually start with 5 multiples, but you guys can start with however many you need. But just a reminder that if you cannot find a common multiple within the first 5 or 6, then you keep going. Okay, you keep going. So let's see. We have 4, 8, 12, 16, 20. So here's the first 5. So let's look if we have a common one. I don't see 7, 4, or 12. So I don't have a common one yet. So I'm going to keep going. Still don't have a common one. So again, I'm going to keep going. Now I see that I have a common one. I have a common multiple, which is 28, which is going to become our new denominator. All right, so now we're going to change our old fractions to our new fractions with our new denominator. So we have 5/7. We have to change it to our new denominator of 28. And then we have to change 3/4 to our new denominator of 28. So again, we look at how did we get from 7 to 28. I'm going to count how many multiples it took. 1, 2, 3, 4, which means we multiplied by 4. So 7 times 4 is 28. We push the 4 up, multiply the top. 5 times 4 is 20. Now let's move over here. What did it take for me to get from 4 to 28? Count my multiples. 1, 2, 3, 4, 5, 6, 7. 4 times 7 is 28. Move up the times 7, multiply the top. 3 times 7 is 21. So now I have two new fractions. I'm going to rewrite my problem with my new fractions. Remember, your whole numbers stay the same. So it would be 1 28 plus 2 21 28. So now that our denominators are the same, we can go ahead and add them. So I have 1 plus 2, which equals 3. And then I have 20 plus 21, which would be 41 28. If we notice though, our fraction here is considered improper. So improper fraction means that your numerator is larger than your denominator, which means within this fraction we actually have another whole. So here's what I'm going to show you how to change that. So I'm going to just kind of put 3 to the side here, okay, because we know we have 3 wholes, but then we're going to break up this 41 28. With this denominator, this fraction would be whole when we have 28 out of 28, okay? Because remember, a whole fraction is when you have the same numerator and the same denominator. So it would be 28 28. So what we're going to do is we're going to actually take 41 28 and we're going to subtract a whole out of it, 28 28. Okay? When I do this, that means I'm taking this whole and I'm putting it really to the 3. So this whole is getting added to the 3 because I have a whole right here. So we're going to plus 1 to the 3 which would be 4. Now, the reason we're subtracting here is because we need to figure out what fraction is left. So if I take 41 minus 28, I'm going to do that over here. 41 minus 28. We have to borrow from the 4, making it 3. This 11. 11 minus 8 is 3. 3 minus 2 is 1. So we would be left with 13 28ths. Okay? So again, when you have an improper fraction, you're going to take away a whole from it. Take that whole, add it to your whole numbers, okay? Because there is an extra whole in here. So you're adding it to your whole numbers, and then you subtract it to figure out what fraction you have left. Okay? So our answer would be 4 wholes and 13 28ths. Okay? Another way to figure this out is if you just draw a picture, because we don't want to leave our fractions as improper fractions. We want them to be proper, which means the numerator is less than denominator. Okay? All right, so now I'm going to show you one where we have to borrow. So I'm going to switch my page here. So our problem is going to be 4 2/3 minus 1 3/4. So again, we look at our denominators to tell us what numbers we use to find the multiples. So we have 3 and 4. 3 multiples are 3, 6, 9, 12, 15. Let's see, 4, 8, 12. I'm going to stop because I already see a common multiple, which would become our common denominator, our new denominator. So 12 is becoming our new denominator. We need to switch our old fractions, 2/3 to the new denominator. And then we need to switch 3/4 to the new denominator. So how did we get from 3 to 12? Well, if I count my multiples, I have 1, 2, 3, 4. It's the fourth multiple, which means we multiplied by 4. Move the 4 up. Then you have 2 times 4 is 8. Now let's go over here. How did we get from 4 to 12? I can count my multiples. 1, 2, 3. I multiplied by 3. Now I'm going to move the 3 up. Multiply the top by 3. 3 times 3 is 9. So now I have created my new fractions. Now I'm going to rewrite my problem entering the wholes. So 4 stays the same. Now I have 8 12ths minus 1 and 9 12ths. So when we were drawing pictures, we realized we cannot subtract 9 from 8, right? So we had to borrow from the whole. So again, you could totally draw a picture to help you figure this problem out. But I'm going to show you how you can do it without drawing a picture. So when we have something like this where we have more that we need to take away than what we actually have, the first thing you're going to do is take away how many you can take away. So right here I have 8 and I need to take away 9. Well, I can take away 8 from here, which is going to, if I subtract 8 from here, it's going to leave it with 0. So this would now become 4 0 12ths minus 1. Since I was able to take away 8, I'm going to subtract 8 from 9, since I was able to take away 8. Okay? So 9 minus 8 is 1. So I still have to take away 1 more 12th. This is where we borrow from this whole, because we can't take 0 minus 1, right? We have to borrow from the whole. So when we borrow from the whole, we literally are subtracting a whole. So this would be 3 now, because we have to take a whole from 4. So a whole in this fraction would be 12 out of 12, right? 12 out of 12 would be a whole. So we took a whole from the 4, we put it as the fraction, and the whole number became a 3, because we're borrowing from this whole. So now, keep the second part the same. Now I can subtract, right? Because I have 12 minus 1. So 12 minus 1 is going to be 11 12ths. Now I subtract my whole numbers. 3 minus 1, which would be 2. Okay, so I'm going to go through that just one more time. So when you cannot subtract or you have a higher number to subtract, what you're going to do is you are going to subtract however many you can. So here I was able to take away 8 from my 9. When I took away 8, it turned it to 0 because that means it's gone. Now, and then since I was able to take away 8, I was left with still one more to take away. I still had one more that I had to take away. So since we cannot subtract 0 from 1, or 1 from 0, we have to borrow from our whole. So the whole goes down, we take that whole and we turn it into the fraction. Then we're able to subtract. Okay? And again, you can totally draw a picture of this to help you understand why this would be the answer. All right? Okay, this is the end of video 2. For mixed numbers, go ahead and